In this video, we're going to learn how to use elimination method to solve system of equations. Please pause the video and copy down this sentence. Elimination method is a method for solving systems of equations by adding or subtracting to eliminate a variable. Okay, that's really important because that's in essence what we're going to be doing for the rest of this lesson. How do we do that? Step one, we have to make sure that all the equations are lined up. And then we're going to add or subtract the equations to eliminate the variable with common coefficients. So we have to make sure that the coefficients have common coefficients together. And then we simply solve the remaining variable. And after that, we substitute. We've used this word very often. We substitute your answer into the one of the original equations and then solve for the other variable. Let's look at example number 1. I have the first equation as y equals 3x plus 4, and the second equation as y equals x minus 2. Also notice that I've got a common coefficient of 1 in front of the variable y. So we, according to our steps, once we find that, we can use equation 1 subtracting equation 2. So let's do that. If I use the first equation, subtracting the second equation, y minus y equals 0. 3x minus x, I have 2x. Be careful here, 4 minus, so I'm going to plus 4 minus 2. So I have 2x plus 6 on the right. And now if I subtract 6 on both sides, I would have 2x equals negative 6. Therefore, x equals negative 3. Negative 3 once I divide 2 on both sides. So now I substitute into the original. Take either one. I like this one, y equals minus 2, because it's easier. I don't have y, but now I know x is negative 3. I put it in here. I just solved y equals negative 5. So the answer for this one, x value is negative 3, y value is negative 5. And if you graph this out or use the substitution method, you should find the exact same answer here, where these two lines intersect with each other. Okay? Let's look at the second equation. Second example, I have x plus 4y equals 13. That's the first one. And x minus y equals 3. So that's the second one. So again, here I have common coefficient of 1 there. So I'm going to use 1 minus 2. Equation 1 minus equation 2. So if it's a minus, that gets canceled. 4y plus 4y minus a minus y equals 13 minus 3. So now double negatives makes a positive, and I would have 5y equals 10, and y would equal 2, right? Now if I substitute it into either one, I'm going to pick equation 2. Positive 3. So I don't know x minus, I know y is 2, so now I just add 2 on both sides, and x equals 5. So now this system intersects, these two lines intersects at 5, 2. Can you try to finish the third one by yourself? And I can give you the answer is 8, 1 is the coordinate where the two lines intersect. Okay. Make sure to pause the video and then come back to number 4. I'm going to move this up a little. So number 4, notice that the common coefficients is here. So, and they're exactly the same. So if, in order to eliminate that, I have to use the first equation subtracting the second one. So 4x minus 2x plus 2y minus 2y is 0 equals 6 minus 18. So double negatives makes a positive, and I should have 6x equals negative 12, and x equals negative 2 after I divide both sides by 6, right? And then I can just plug in either one. It doesn't really matter. I'll plug in the first one. So 4 times negative 2 plus 2y equals 6. And that's negative 8. And then 2y should, if I add 8 on both sides, that's how I get 14. And y is 7. So the answer to this one is negative 2, 7. Okay? So it's not hard at all, but you do need to find the variable that has common coefficients. If their signs are different, meaning one is plus, one is minus, you add them. If they're exactly the same signs, which is what we've been practicing, you subtract them, just with the hope of eliminating them. So let's look at the next page. Here comes the ones with different signs. So let's look at the first equation, 4x plus 9y equals 5. And the second one, I have negative 4x. So the coefficients are opposite. In this case, to eliminate the first term, the x term, I add the 2 together. So I add 4x plus minus 4x, in other words, 4x minus 4x gets canceled. 9 plus 7 is 16y, and 11 plus 5 is 16. So y is 1, and then I simply plug it in to the, I'm doing the first equation. So 4x plus 9 times 1 equals 5. 4x equals 5 minus 9. X should be, 4x equals negative 4. Therefore, x equals negative 1. So negative 1 and positive 1 is where these two meet. Number 6, again, notice right here. I like these much better. These are my favorite because you notice the coefficients are opposite. So I simply add the first equation with the second equation. That's how I cancel them, right? And then if I add them, 10 minus 2 becomes 8x plus 0 plus 84. 8x equals 84, x has to be 3. And then if I plug into one of them, 10 times 3 minus 3y equals 18. So 30 minus 3y equals 18. If I subtract 30 on both sides, I should have negative 12. And now if I divide 3 on both sides, y should come out to be 4. 3, 4 is the coordinate where these two lines meet if you plot them out. So try number 7 by yourself. You should come up with 7, negative 3. Remember to pause the video. Okay. Try number 8 as well. 5, negative 2. And now I will demonstrate the last 4. Now, last 2, I'm sorry. Look at these. These are kind of unique, right? The coefficients for x and y are exactly, for x and our common coefficients. And then we have another pair in y. So let's practice what we've been practicing. I'm going to label equation 1 and equation 2. Because they're exactly the same, to eliminate them, I have to use subtraction. So 1 minus 2. This becomes 0 minus 0 becomes negative 10 minus 13. So it's negative 10 plus 13. On this side is 0. And obviously, it becomes 0 equals 3. And we all know 0 and 3 are two numbers. So this is a special case where it's a null. It's invalid. It's undefined. You can write null like that, or you can write undefined. Excuse me. Okay. Now the next one, look at number 11. I have standard form, 2x plus y equals negative 10. This is called standard form because x and y is on one side and the constant negative 10 is on the other side of the equal sign. And here, I have negative y equals 2x plus 10. It's sort of slope-intercept form, but it's not, because slope-intercept form, the y doesn't have a negative sign in front of it. Regardless, remember, the first step we have to do is to make sure they're in the exact same form. So I'm going to play around with the second one first, okay? So what I'm going to do is I want to have all the x's on one side. So I'm going to minus 2x on both sides. I end up minus 2x minus y equals 10. Now I'm going to put this back together. I'll change my color. So I have, if I call this first equation, 2x plus y equals 10, I'm just going to copy it down. And then I have the second equation. It's exactly the same thing. I just rewrote it. That's negative 10. I just rewrote it. And this is first equation, and this is second equation. And now notice that there's a 2 there. There's a negative 2. So all I need to do is to use the first equation plus the second equation. I add them together in order to cancel that. And notice that if I cancel that, I have 0, but I also ended up canceling y. And then I ended up canceling the constant on the right-hand side. So my final conclusion is 0 equals 0. And that's always a true statement. It means that whatever I put in x, it doesn't matter. Whatever number I put in y, it doesn't matter. These two lines are always together. And in this case, my answer is infinity. From negative infinity to positive infinity. Okay? So again, just a quick review. If you solve the equation to the point that you have a true statement, 0 equals 0, no matter what, x, y doesn't matter, that's when you have the answer as infinity. But if you solve the equation to come up with a false statement, and that's when you have an undefined answer, meaning these two lines probably parallel. They don't have any intersections with each other. Okay, that's it for today. Please continue with your practice in the next 2 pages. Thank you, guys.